Welcome back to Pre-Algebra with Miss Betsy. Today what we're going to be talking about is some little patterns, rules that we can use to determine if it's possible to divide a number by 2, by 3, by 4, 5, 6, 9, or 10. And these are some little tricks that will help us to be able to factor numbers so that we're able to reduce fractions to their lowest terms. If you happen to be using Bob Jones University Press's text, Pre-Algebra for Christian Schools, first edition, this corresponds to section 5.2, and this is found on page 148, but it doesn't matter if you're not using that text. The material and the information, the concepts are the same. Before we begin, however, can you tell me what it is that starts with an E? It ends with an E, but it only has one letter in it. Well, that, of course, would be an envelope. So this video for today is a very quick one. These are what they call divisibility rules. Whether you think of it as a trick, or an algorithm, just some pattern that you're looking for, or just a rule, or just something that you want to memorize. This is very helpful to you. First off, how do you tell if you can divide a number by 2? Well, if a number is even, you can divide that by 2. But first off, what do we mean if we say, is this number divisible by 2? Is 48 divisible by 2? That means when you take this number that they're asking us and we divide it by 2, do we end up with a whole number? 48 is divisible by 2 because 24 plus 24 is equal to 48. Now, if you're thinking, and you might tend to think of this using the language of every day as saying, can you evenly divide something amongst a group of people? Let's say that you have 2 people and you have 3 cookies, and they're not teenage boys where they fight over who gets all 3 of them, but you wanted to divide those 3 cookies evenly between the 2 people. Well, each person would get 1 whole cookie. You would take the 3rd cookie, break it in half, so that each of you had 1½ cookies. But they're not evenly divided, so 3 is not divisible by 2 because you have to use fractions. If you have 4 cookies, each person gets 2. If you have 6, they each get 3. If you have 8, they each get 10. If you have 8, they each get 4. But if you have 1 cookie, 3 cookies, 5 cookies, 7 cookies, or 9 cookies, you would have 1 cookie left over that you have to break in half. So even numbers are those numbers that end in 0, 2, 4, 6, or 8. Those are always going to be divisible by 2. And then how can you tell if you can divide a number by 5? If the last digit of that number is either a 0 or a 5, you can divide the number by 5. Because what we're doing is we're counting by 5s. When we count by 5s, it's 5, 10, 15, 20, 25, 30, 35, 40. The last digit is either a 5 or a 0. So when you're dividing by 5, you can do that evenly as long as the last digit of the number is a 0 or a 5. In order to divide by 10, the last digit has to be a 0. Think of it. 10, 20, 30, 40, 50, 60, 20,010, 20,020. Always has to end in a 0. So these are the most common divisibility rules that we have. If we have 72, is that divisible by 2? Yes. It's even. Is it divisible by 10? No, it doesn't end in a 0, and it doesn't end in a 5, so it's not divisible by 5. What about this one right here? 75. Is it divisible by 2? No, it's not even. By 5? Yes, it ends in 5. By 10? No, because it doesn't end in 0. What about 80? 80 is even, so it's divisible by 2. It ends in 0, so it's divisible by 5. It ends in 0, so it's also divisible by 10. So this is our first grouping of divisibility rules. Now the next grouping of divisibility rules that we have are by 3 or by 9. Same rule. This is what we call sum of the digits rule. And it's not SOME, but it's the sum of the digits. Let's take a number, 123. 123. As I write 6, because my hand has already gone to where my mind is going ahead. If we have 123, this number is composed of 3 digits, a 1 in the hundreds place, a 2 in the tens place, and a 3 in the units place. If we take those 3 digits and we find their sum, in other words, if we add them together, 1 plus 2 plus 3, we find out that their sum is equal to 6. To figure out if you can divide a number by 3 or by 9, first we find the sum of the digits that comprise that number. And then we see if we can divide that sum by 3. Is 3 divisible by 6? Sure. 2 times 3 is 6. If the sum of the digits is divisible by the number, then the entire number is divisible by 6. Same thing for 9. We're still going to take all of these digits and we're going to add them up. Can you divide 6 by 9? No. So 123 is divisible by 3 by 3, but not by 9. Now let's see if this is really the case. 123 divided by 3, 3 goes into 12 4 times, 3 goes into 3 1 time. 3 times 41 is equal to 123, which is what our little rule said. We added up the digits. 6 divides by 3, so you can divide that whole number by 3. Can you divide this by 9? Now our rule tells us that you can't, because you cannot divide 6 by 9. So let's see what happens. 9 goes into 12 1 time. We subtract to get 3, bring down the 3. And there's no number that you can no whole number, that you can multiply by 9 to arrive at 3. The closest you get is 3 9s or 27, but you have a remainder of 6. So 123 is not divisible by 9. However, if we took 1,233, that's going to be divisible by 3 and by 9. 1 plus 2 plus 3 plus 3 is equal to 9. You can divide 9 by 3, and you can divide 9 by 9, of course. Let's go ahead and verify this, illustrate it for you. Over here we have 1,233 divided by 3. 3 times 4 is 12. 1 times 3 is 3. 1 times 3 is 3, and there's no remainder. It divides evenly. 3 times 412 is 1,233. 3 times 400 is 1200. 3 times 11 is 33. Now let's go ahead and illustrate that you can also divide by 9. 1, 2, 3, 3, divided by 9. 9 goes into 12 one time. You subtract, you have a 3, bring down the 3. 9 goes into 27 3 times. 3 times 9 is 27. You subtract, you have 6, bring down the 3. 7 times 9 is 63. There is no remainder. So 1,233 is divisible by 9. 9 times 137 is 1,233. So these are the divisibility rules. By 3 and by 9 we use the sum of the digits. There's another rule, two other rules that I want to mention to you, and these are both helpful. We want to know if you can divide a number by 6. It must be divisible by both 2 and 3. If you want to know if you can divide a number by 6, it has to be divisible by both 2 and by 3. I don't tend to ever use this divisibility rule, but it's a true rule. The other one is, how do you divide it? Tell if you can divide a number by 4. This is, you look at the last 2 digits in the number, and you consider it to be a whole number by itself. For example, if you have 1,024, that is divisible by 4, because what you do is you look at the last 2 digits here. You look at 24. 24 is divisible by 4. 4 times 6 is 24. So 1,024 is divisible by 4. If I illustrated it, I don't guess that I want to go ahead and do this without writing it. Let me get a different marker so that you can see it more clearly. And the board has gotten so messy. Let me clean this off. 1,024 is divisible by 4. I'm saying because the last 2 digits you can divide by 4. 4 goes into 10 2 times. Bring down the 2. 4 times 5 is 20. Subtract and bring down the 4. 4 times 6 is 24, and there is no remainder. So 1,024 is divisible by 4. This shows up, you can use this to know if a number is a leap year, like the year 2012, this was a leap year. We had February 29th. Any number that is evenly divisible by 4, any year that's divisible by 4 is going to be a leap year. 2012, our rule tells us that this is divisible by 4 because the last 2 digits taken as an entire number. 12 is divisible by 4. 4 times 5 is 20. Bring down the 1. You cannot count any 4s out of 1. 0 times 4 is 0. Subtract and bring down the 2. And we see that yes, in fact, our current year, 2012, was a leap year because it is divisible by 12. And that's just a little factoid, meaningless factoid if you want to calculate if a year is a leap year or not. If it's divisible by 4, it's a leap year. So, we have little tips and tricks that we can remember to tell if we are dividing by lots of different numbers. How do you tell if you can divide by 2? It's an even number, which means that it ends in a 2, 4, 6, 8, or 10. You use the sum of the digits rule for 3's. You add up all of the digits. 123 is divisible by 3 because you add the digits together. 123, you have 1 plus 2 plus 3 is 6. 6 is divisible by 3, so the entire number is divisible. Sum of the digits. With 4, let's look at the last 2 digits. With 5, let's catch up. Last 2 digits. You go ahead and erase this. For number 3, what did I say? I said we had the sum of the digits. For evenly divisible by 5, the last digit is either a 5 or a 0. To see if it is divisible by 6, it has to be divisible by 2 and by 3. How do you tell if it's divisible by 9? That's another sum of the digits. If you can divide the sum of the digits evenly by 9, you can divide the entire number by 9. And finally, a number is divisible by 10 if that number ends in 0. These little hints will help you when you're dividing numbers. I'll see you next time.